Hi everyone! In this video, I'll be walking you through the SkyCiv plugin for Grasshopper, now updated to version 2.0. This latest version brings major enhancements, making your structural modeling workflow faster, more flexible, and more intuitive. You can download the plugin in a few different ways. Inside Grasshopper, open the package manager and search for SkyCiv. Select SkyCiv GH plugin. The latest version is v2.0.7 beta, and you can install it directly from here. You can also download the plugin by visiting our website at skyciv.com and download it by navigating to API, app integrations, and add-ons. It's also available on Food for Rhino. This version introduces direct input modeling, no more relying on dialog-based inputs. You can now define members, plates, supports, and loads directly through component inputs, giving you more control and a more transparent modeling experience. Once installed, you'll see a SkyCiv tab in the Grasshopper ribbon. Inside this tab are multiple submenus for building your model, modeling tools, creating nodes, members, and plates, loads, point loads, distributed loads, vibrational loads, and self-weight, plus tabs for supports, load combinations, materials, sections, output, analysis, and more. Here we're working on a sample steel shed model. Let's walk through how to set this up using SkyCiv's updated components. In v2.0, you can define members using different geometry types with the new SkyCiv member from 𝗶𝗁𝗁𝗁 component. This allows you to use brep, line, or curve to define members. Alternatively, use SkyCiv member from points if you prefer defining geometry from coordinates. You have full flexibility when defining sections and materials. For materials, use SkyCiv Material DB to select from SkyCiv's pre-configured default materials options, or build your own custom material using SkyCiv Material Custom, entering values like Young's modulus, density, and Poisson's ratio. Use SkyCiv Section DB to choose from our built-in section database by region, shape, size, and material. You can also define custom sections by using the SkyCiv Section Custom component, which includes shape templates like rectangular, circle, eye shapes, and more. We've selected the rectangular shape template here. Depending on the shape you choose, the input fields will adjust automatically. For example, since we chose rectangular, we now see depth and width as inputs. You can then connect your material component directly to the material input of this section using standard Grasshopper wires, ensuring the section is properly linked to the material properties you've defined. Once you've created your materials and sections, you can start assigning them to your members. You can create members using the SkyCiv member from 𝗶𝗁𝗁𝗁 component, or if you've already defined your members, simply connect the section component to them using wires. To create plates and defined surfaces, you can use components like SkyCiv Surface Plates, which creates plates from surfaces or mesh, or you can use SkyCiv Nodes Plates component, which creates plates using node inputs. You can also define plate pressures using SkyCiv Linear Plate Pressures or SkyCiv Uniform Plate Pressures components. Once your geometry is defined, it's time to apply loads. SkyCiv supports several load types. For point loads, use components SkyCiv member PL or SkyCiv nodal PL. For distributed loads, use the component SkyCiv distributed load. And for area loads, use the component SkyCiv area load. You can define loads using either magnitudes or start and end vectors for more control. Supports can be added with the SkyCiv support component. Specify the type, either node or line support, and define the restraint code. For more control, use SkyCiv restraints component to define the translational and rotational degrees of freedom, and then feed that into the support component. Once you've defined your geometry, loads, and supports, connect them all using the SkyCiv Assemble component. This component is used to assemble the various components of the model, including beam, plate, support, load, pressures, and others. This will create your model, and the component can be directly fed into the SkyCiv Model Writer component. From there, use the SkyCiv Model Writer to export directly into S3D. No manual import needed. Just click Launch S3D and your model will open automatically in SkyCiv S3D as long as you're logged into your account. Once your model is open in S3D, you'll see that any changes made in Grasshopper will automatically reflect in S3D. This live polling ensures a seamless back and forth without needing to relaunch the model every time. You'll notice that all of your sections, geometry, loads, and supports are in your model. Once you're done reviewing, click Cancel in the bottom right corner to stop the sync. To perform an analysis directly in Grasshopper, use the SkyCiv Analysis component, feed in your model, and choose an analysis type. In this case, we're running linear static. Click Run Analysis. A pop-up will confirm the analysis is in progress. Once complete, results are displayed in a tabular format, easy to review. You can browse through different tabs to see member forces, reactions, and other outputs. Coming soon, we're also adding visualization tools so you can view results directly in the Rhino viewport and download a full report. This update brings a huge leap in usability, transparency, and modeling speed for structural engineers using Grasshopper, with support for flexible geometry inputs, advanced loading, live model syncing, and in-app analysis. SkyCiv Grasshopper Plugin v2.0 helps you work smarter. Download it now via Grasshopper Package Manager, Food for Rhino, or directly from our website at SkyCiv.com. And for full documentation, check out the SkyCiv Grasshopper Plugin docs. Thanks for watching!